In this lecture, we'll talk about the product rule and the power rules for exponents. We will evaluate the exponents and identify the base in the exponent. We will apply the product and the power rules for exponents. And we'll also go over the combination of product and power rules. Let's get started. First, we will evaluate the exponent and we'll identify the base in the exponent. Here's an example. 3 squared equals 3 times 3, which equals 9. In this case, my base is 3 and my exponent is 2. So my base 3, which I'm multiplying twice. Exponent is the number which tells you how many times you multiply your base in order to evaluate and get the answer 9. Let's do some more evaluation on exponent, and we will also identify the base in the exponent. Here I have an example with the base to be negative. The negative 3 is inside the parenthesis. So my base is negative 3. My exponent is 2, which means I'm going to multiply my base negative 3 twice. When I multiply negative 3 twice, negative times negative will become positive. Anytime you multiply the negative sign even number of times, 2, 4, 6, 8, 10, or so forth, the answer will be always positive. So in this case, I got positive 9. So my base is negative 3 here, and my exponent is 2. Let's look at the same example, but this time I have removed the parenthesis around it. In this case now, my base will change because negative 3, if you imagine, is the same thing as negative 1 times 3. So there are actually two factors. So if you want to include both, you need a parenthesis. So in this case, I will not include the negative sign as my part of my base. My base will be only 3 and my exponent is 2. So in this case, I will multiply my base 3 twice and the negative sign stays outside. And in this case, I will get negative 9 because 3 times 3 is 9, and you will bring down the negative sign. So this is a very important concept that you must make sure get hang of it in order for later on to do the combination rule. So if you want to include the negative sign as the part of the base, you must use a parenthesis. That's the idea. We will try a few more. Here I have negative 5 inside the parenthesis and exponent is 3. So obviously you can see because I include the negative sign inside the parenthesis, my base is negative 5 and my exponent is 3. I'm going to multiply negative 5 3 times. Now, whenever your negative sign appears odd number of times, for instance, 3, 5, 7, 9, 11, and so forth, the answer will stay negative. So I would multiply 5 times 5, 25, and 25 times 5, which will give me 125. Because I'm multiplying odd number of times, it's going to be negative 125. And my base, as you can see, it's negative 5, and my exponent is 3. Let's look at the similar problem again, this time without the parenthesis. So now you know the base will be only 5. I will not include the negative sign. This is not inside the parenthesis. The exponent is 3. So when I multiply, I leave the negative sign outside and I multiply 5 times 5 times 5, which will still be 125. And I'm going to bring down the negative sign down. So in this example, when the power is odd, you use the parenthesis or not, the answer is still remaining the same, but your base is still different. Your base is positive 5 here and exponent is 3. Let's try 2 more examples. This time, I have a negative sign outside the parenthesis and inside the parenthesis. Keep in mind, exponent goes first before you multiply. So in this case, my base is negative 2 and my exponent is 4. I'm going to leave the negative sign outside the parenthesis, and I'm going to multiply -2 4 times inside the parenthesis, just like this. Now, let's recall what I said earlier. The negative sign appears 4 times, which is an even number of times. When you multiply negative sign even number of times, the answer will be positive. So 2 times 2, 4, 4 times 2, 8, and 8 times 2, 16. Inside the parenthesis, I will have positive 16. Now, because the negative sign is outside the parenthesis, negative and a positive, the final answer will turn into negative. So in this case, my base was -2 and my exponent is 4. Let's do one more, this time with the odd exponent. So I have the same scenario, it's just exponent is odd. So in this case, my base will be -2 and my exponent is 3. I will multiply the negative sign inside the parenthesis 3 times, just like this. Let's recall again, negative sign appear 3 times, will stay negative. So inside the parenthesis, when I try to evaluate, I will have 2 times 2, 4, 4 times 2, 8, but the sign will stay negative. So in this case now, I will do negative times negative, and the final answer will become positive. So the base was -2, and the exponent is 3. As needed, before we jump into the rules, if you need this concept again, please stop, pause, and go over again. Now we will identify the base and exponent only. Here's an example. I have 3x parenthesis power 2. So in this case, my base is what's inside the parenthesis. So my base is 3x, my exponent is 2. We're not simplifying this at the moment, but we will do this later on. Let's try one more. Here I have 6x to the power 5. Now it's actually 6 times x to the power 5. Let me get the pen here just to explain you. So you see that this is a times here, multiplication. The 5 is directly touching to the x. If I wanted the 6 to be part of my base, then I must use a parenthesis. Keep in mind. Because the 5 is only touching to the x, in this case, my base will be x and my exponent will be 5. So I will not include 6 as part of my base. If you wanted to include the 6, then you must put 6x inside the parenthesis. In that case, your base will be 6x. So here we begin with our first rule, product rule for exponents. It's also called the multiplication rule for exponents. Please go ahead and copy down the rule because you might need that in order to simplify the examples in the next slide. A to the power m times a to the power n equals a to the power m plus n for any positive integers m and n. So the two things that you need to keep in mind in order to use the product rule is that first of all, you need to make sure that you're multiplying. You're not adding, subtracting, or dividing in this case. You have to have a multiplication sign. The second thing is that you need to make sure the base is same. In this case, my base is a and a. If those two things are checked, then you will keep your base a and you will just add the exponent m plus n. We will try some more example on the product rule now. So one more time, it's a to the power m times a to the power n equals a to the power m plus n. Check the base must be same and check that you're multiplying the exponents. Here are the examples. So let me get the pen here. Now it doesn't matter whether you have multiplying 2 exponents or 3. As far as the conditions that I mentioned earlier satisfies, you can still use the product rule. So here I have 4 and 4, the base is same, checked. And here I'm multiplying, checked. So it means I can use the product rule and I can write this as 4 is my base, so you want to leave the 4 as is, and then you will add the power 3 plus 5. So 3 plus 5, the power is going to become 8. And you just did the product rule. So you can use this rule even for the variables. Okay, so P here, and P. The base is same. And you want to make sure that you're multiplying, which means I can use the product rule. So when I write your base P one time, and now you will add the exponent. 2 plus 8 is 10. 10 plus 4 is 14. So your exponent is going to become 14. And this is your product rule. Let's try 2 more examples on the product rule. This time I'm going to do a little bit differently. Now, when you multiply, there are 2 ways to show multiplication. The one is using a dot, and the other one here I have used is a parenthesis. They both means to multiply. So in the first example, when I'm multiplying, first of all, I'm going to multiply the numbers. So 4 times 3 is just like a whole number. So you're multiplying 4 times 3 is 12. Now I'm going to use the product rule on the variables. So now I have to do my checkpoint that the base is same, the x and the x. And I'm already multiplying as I showed you the sign earlier. So I'm going to leave my base x as is. And you must add the exponent 5 plus 9, which will give you 14. And that is a product rule. Let's try one more. In this case, instead of the dot, I use the parenthesis, but the check mark is done. It's a multiplication. The base is same for the case. So first of all, I'm going to multiply -5 times -7, which will give me +35. Now, for the case, you need to check the base is same. So I'm going to keep my k one time. And then I'm going to add the powers on the k, 6 plus 3, and that's going to give me 9. So remember, one more time, you just multiply numbers in the front, and if the variables are same, you can keep the variable and just go ahead and add the exponent in order to multiply 2 exponents. Let's move on to the power rule for exponent. We have 3 power rules. This is the first one I'm showing you. So raise a power to a power by multiplying exponents. So for any positive integers m and n, you have a to the power n, m raised to the power n. So when you have a power and then again the entire thing, you have a power again, you have so much power that you multiply those 2 numbers. So you just multiply m times n, and that way you will able to get rid of the parentheses. Let's look at this with the example now. Here are the example. I'm going to show you 3 examples. So make sure you copy down. The first example, I have 7. Now keep in mind, the 7 is outside the parenthesis, right? So I will not touch the 7, and I'm just going to copy my 7 as is. Now, here it is about power to the power. X to the power 7, which is raised again to the power 9. When you have a power and a power, you multiply them to get rid of the parenthesis. So I'm going to leave my x, and then I will multiply simply 7 times 9, and that should give me 63. So this is an example of the power rule. Now, you have to be careful when you have a negative sign inside the parenthesis. For instance, here you have a negative sign. So when you have a negative sign, you're looking at the power 4 outside. In a previous slide, I mentioned when you have a negative sign, even number of times, it will become positive. So when I multiply here, negative sign 4 times, it becomes positive. So I don't have to worry about this sign when I open my parenthesis. So my base is the 5, which I will leave it. And I'm going to multiply 6 times 4, which is power to the power, and that should give me positive 24. So once again, I use the power rule. Let's try one more. This time I have a negative sign, and that is being raised to the power 5. That is an odd number. When the negative sign you multiply odd number of times, it will stay negative. So in this case, I can't get rid of the negative sign. My base is 3, which I'm going to keep it here, and then multiply power in a power, 3 times 5, which will give me 15. So this is our first power rule. When you have a base and a power, which is again raised to the power, you will simply multiply those two powers. Here is my power rule number 2. I'm writing power 3 because we are including the product rule. That was the first rule. Then we learned the first power rule. This is our second power rule. So this is actually our third rule. Raise a product to a power by raising each factor to the power. For any positive integers m and n, a times b to the power m equals a to the power m, b to the power m. This rule explains us when you have more than one factor inside the parenthesis, how you can get rid of the parenthesis. So you're basically distributing your exponent to each factor inside the parenthesis. In this case, I have two factors, a and b. So when I open my parenthesis, I distributed m to the a base and I distributed m to the b base. Let's look at the example on this rule. Here I have two examples. In the first example, let's identify how many factors I have. I have 8, I have p, and I have q. Basically, I have 3 factors, and therefore I'm going to distribute this 3 times. So in this case, I will write 8 to the power 3. Then I will write p to the power 3. And then I will write q to the power 3. And the rule is used. This is again a power rule when you have more than one factors inside. In the second example, the 9 is outside, and therefore I will not distribute the power 4 to my 9. I will only distribute on the x and the y, because the 4 is directly touching the parenthesis, and inside the parenthesis, those are the factors that you will distribute your power 4. In this case, I'm going to keep my 9 as a 9, and I will distribute my power 4 on the x, and I will distribute my power 4 on the y. Let me just write this again. It's 9x to the power 4 and y to the power 4. Okay, let's look at another power rule. Now this rule is when you're dividing. So raise a quotient to a power by raising the numerator and the denominator to the power. Here's the rule. For any positive integers m and n, a over b to the power m equals a to the power m divided by b to the power m. B not equal 0, I have to use as a restriction anytime you are using denominator as any variable. Because variable can have any value, and if the denominator is 0, then the whole thing becomes undefined. So A could be a number, a B could be a number, A or B could be a letter. What basically you are doing is that the fractions that you have inside the parenthesis, in order to get rid of the parenthesis, you're distributing your exponent to the numerator A and the denominator B. Let's look at the example based on the power rule 4. Here I have two examples. Now, when I'm using the numbers, I'm not going to put any restriction because the denominator cannot be 0. Only time I put the restriction in the question if I have a variable as a part of my fraction in the denominator. So for the top problem here, as you can see, 4 is my numerator and 5 is my denominator. So I'm going to distribute my 6 to the 4, which is a numerator, and I'm also going to distribute my 6 to the denominator 5. So the answer here is 4 to the power 6 over 5 to the power 6. Same thing I'll do here. My numerator is p and my denominator is q. I will distribute the 4 to to the p, which is the numerator. I'll distribute the 4 to the q, which is my denominator. So this thing is only because my denominator is a variable, and we need to make sure that variable cannot be 0. Now we will try the combination of rules. So combination of rules, you can use any rule of your choice first. So this can be done different ways depending on which rule you're using first. So for instance, in this case, I could have used, I can first get rid of the parenthesis by distributing 3 to the power 5, 4 to the power 5, 3 to the power 6, 4 to the power 6. Also, I can use a product rule. As you can see, it's a multiplication and the base are same. Well, the choice is yours. I would like to use a product rule, the first rule we went over. So in that case, I'm going to keep my base 3 over 4 as is, and I will add my exponents because I'm multiplying. The first rule was for multiplying exponents. So from there, I'm going to get 3/4 to the power 11. So I used first rule. Now I'm going to use the last rule that I showed you. So my numerator is 3, my denominator is 4, and I'm going to distribute 11 to the numerator and 11 to the denominator in order for remove the parenthesis. So from here, I'm going to get 3 to the power 11, 4 to the power 11. Now, if the exponents were like smaller numbers, 2, 3, or up to 4, probably I would have evaluated. But in this case, because the exponent is large, I'm just going to leave my answer in the form of an exponent. So if you want to pause here and try using the other rule first, you can. Eventually, you will still come up with the same answer. Let's try another one. X squared to the power 3 times x cubed to the power 5. Now, this was the second rule we learned for the power rules. We have a power and a power and a power and a power. So we're basically just multiplying to get rid of the parenthesis. So that's how I get x to the power 6 and x to the power 15. I put x inside the parenthesis. If you don't want to put inside the parenthesis, that's completely fine. Now, because the base is same, x, now I'm using the first rule, which is a product rule. So I'm going to keep my x as is, and I will add my exponents 6 plus 15. That will give me x to the power 21. So in here, I used the power rule, the second rule that I showed you after product rule, which multiply power and a power, and then I used the first rule, which is a product rule, keeping the base x and adding 6 plus 15, which is 21. Let's try one more example. So in this case, I'm going to use multiple rules. Now, first, parenthesis, if you see here, there is no exponent here, right? So we can just get rid of the parenthesis without doing anything. In the second parenthesis, I have a negative sign, which I'm going to do twice, which will give me a positive number. Now, if there's no number, keep in mind the exponent is 1. So when I get rid of the second parenthesis, I'm going to multiply 1 times 2. I'm going to multiply 3 times 2, and I'm going to multiply 3 times 2. So this is how I get negative a to the power 4, b to the 5. That is just by dropping the first parenthesis. The negative sign completely gone, as you can see, because I changed the positive. 6, 1 to the power 2, 6 squared, that became 36. 3 times 2 became 6, and 3 times 2 became 6. So now I'm going to arrange this. I will put the negative sign first, then I'm going to write the number next, and I will use the product rule. So a to the power 4, a to the power 6, that will become a to the power 10. I will use the product rule again on the b. b to the power 5, b to the power 6. You will keep the b and add 5 plus 6. That should give you 11. So my final answer looks like negative 36, a to the power 10, b to the power 11. So one more time, if you needed to pause this and go over again, please do so.